Hello friends, welcome to my channel. Let's have a look at a daily challenge problem. Problem 336, Palindrome Pairs. In this video, we're going to share a solution based on the use of dictionary and prefix or suffix check. So first, we'll read through the statement to digest the main points, and then we do a simple analysis, and finally we share the code. First, let's look at the statement. So given a list of unique words, return odd pairs of distinct indices ig in the given list, so that the concatenation of the two words, so word at index I plus word at index G, is a palindrome. So this is the main statement of the problem. So it contains two main points. One is that the list contains unique words, and the second is that the pair contains distinct indices. So with that said, let's look at the three examples. So we'll start from example 3. So example 3 actually is very simple, but it tells us that the word in the word list can be empty. So empty string, so you put plus a palindrome, no matter you put the empty string in front or back, so the result is still a palindrome. So in example 3, the return is 0, 1, and the reverse is 1, 0. So similarly, you can check example 2, so 0, 1 or 1, 0. So BAT plus TAB is a palindrome, and TAB plus BAT is also a palindrome. So similarly, we can interpret the return of example 1. So example 1 is more or less the generic case. So with that said, let's also look at the constraints for this problem. So we can understand the constraints as additional assumptions for the problem. First, the list of words, so the words array, has length bounded above by 5,000. So this actually partially determines the problem size. So the second one also has to do with the problem size. So each of the word in the words list has length bounded above by 300. So 300 is not a very large number. So these two together actually determine the problem size. So the last one is word I, or each word in the words consists of lowercase English letters. So this one is not that essential for this solution. So with that said, let's look at the analysis. So first, our method involves the use of dictionary and the check with prefix and suffix. So the main point is based on the following observation. So when we examine the prefix or suffix to form palindrome, the below 2 points are the things we pay attention to. We're going to use a string to fix the idea. So here for the first case, we're going to use abacd. So notice that aba as a prefix is a palindrome itself, right? So here prefix aba is a palindrome. Then if the remaining suffix, so that is cd, if we consider the reverse, that is dc. So if dc is in the list, then dc can be added in front to form palindrome. For example, dc plus abacd is a palindrome. So this is the one key point. The second point is sort of symmetric. So similarly, if we consider this one, in other words, I put the aba in the back. So then aba is a suffix. This suffix is a palindrome. And then the prefix is cd. So if we consider its reverse, that is dc. So if dc is in the list, then dc can be added back to the palindrome to form palindrome. So for example, if we add dc to the back, so we get cdaba plus dc. The result is a palindrome. So these 2 points are what we are going to check when we form the palindromes and get the final desired result. So below are the standard procedure. So to get all the desired pairs, we can do the following. So step 0 is a preparation. So we can get a word index dictionary. So this is just for the ease of checking index. So step 1 is that for each word with index I, so we do the above check for all the possible prefix or suffix corresponding to different lists, and then check if the corresponding reverses are in the dictionary in step 0. So here is the two sentences corresponding to point 1 and point 2. So here, if the prefix is a palindrome, and then the suffix reverse is in the dictionary with index G, then GI is a valid pair. So similarly, if the suffix is a palindrome and the corresponding prefix reverse is in the index in the dictionary with index G, then IG is a valid pair. So here is a detailed example. So we're not going to go over in great detail, but the result is here. So the ABADC and CD is corresponding to 1 point we mentioned. So also here, we have A and AA. So 1 point to notice is that we shall avoid self plus self concatenation. For example, A itself is a palindrome, but 00 does not count. Similarly, you can consider AA. 33 does not count, due to the problem assumption that we are interested in distinct indices pairs. So with that said, so let's look at the code. So the code actually is very simple. So notice that in Leetcode, this problem is marked hard. But if we notice the 2 points above, that's the 2 points. So writing the code is actually a verbose translation of the 2 points. So first, I'm going to write a hyperfunction. So let's make it as a preparation. So this function is actually checked if given a string, it's a palindrome. So we're going to return as if it equals as reverse. So actually there are different ways to write the check. For example, we can use 2 pointers to move to the middle from the beginning and end. So, but for the purpose here, so this simple function should be sufficient. And next, we're going to get the word index list. So here we are going to use the assumption again. So the list contains unique words, so we can use dictionary comprehension. So we're going to change this word a little bit. So we're going to go word and the index for I word in enumerate words. So we can do this is because the keys are unique, right? So this is the preparation step. So next, we're going to do the prefix and the suffix check and prepare the final return. So prepare result. So here we're going to initialize a result list or array, so which is going to hold the valid pairs. So the final state of this result variable is what we want to get. So for this, we're going to do iteration. So for word and index in words items. So we are iterating over the dictionary words now. So now first we are going to get the length of the word so that we can check for all different lengths of prefix and suffixes. So then for G in range, so n+1. So we're going to check all the possible cases, including the empty ones. So first we have a prefix and then we have a suffix. So the prefix will go to retrieve the length G part, and the suffix will be starting from the index G then until the end. So this is the two preparation. So now we are going to check this case and this case. So first let's check prefix and check the suffix reverse. So in this case, so if check suffix, prefix, let's see. So in this case, we're going to get the reverse of the suffix. Then we're going to check if the reverse, in other words, if the back were in the dictionary. So then we're going to check if back. So first I want to exclude the possibility of self concatenation. So we want to make sure back does not equal to word itself. And also we want to make sure back is inverse. If this is the case, actually we can add the back in front of the word to form the palindrome. So we get a valid pair of indices. So that is words back. Because back is in the word, so we can track its index and then the index key. So this is one case. And the other case is that we check the suffix. So for the suffix, we should make sure it's valid. So because here we write G up to N, right? So the largest index for the word is N-1. So if G does not equals N and the suffix is also a palindrome. So in this case, so we can actually check the reverse of the prefix. So back is prefix reverse. Then if the back is in the dictionary, then we can put the back in following the original words to form valid indices. So in this case, our check is back does not equal to word again, right? So and back in words. So if this is the case, actually we get a valid pair. So the first index is key, and the second index will be words back. So this two if blocks corresponds to these 2 points. So with that said, so the main logic is done. So next we are ready to do the return. So we are going to return the final state of the result. So this is the full code for this format of solution. So let's first do a special case check. Yeah, it passes the first example. Now let's do a generic case check. Oh yeah, it passes all the test cases. So I would say for this problem, so the main logic is encoded into these 2 observations. So this actually provides a way to build palindrome. So with that said, I guess that's about it for this video. Thank you very much.